Twitter. I would also like to express my appreciation to Kevin Reid and members of West Yorkshire Astronomical Society who provided a number of splendid deep sky images for it appeared in this month's programme. This month I thought it would be a good idea to take a look at some of the highlights of the winter constellations, and along the way we will learn something about the legends of the stars. The first astronomers had no real idea about the nature of the stars. Since no star appeared as anything but a point of light, it was natural to suppose that they were small, since they showed no relative motions. It was equally natural to assume that they were fixed, revolving around the Earth once in 24 hours. It was thought too that all the stars lay at the same distance from us, probably fixed to some sort of solid sphere. This sounds fanciful today, when it is known that the stars are suns and that many of them are much larger and more luminous than the sun we know. Yet we still have a legacy from the old sky watchers, since the constellation patterns which they formulated have never changed. Ptolemy of Alexandria, last of the great astronomers of classical times, died about AD 180. In his best known book, the Almagest, which has come down to us by way of the Arab translation, he virtually summarised the astronomical knowledge of his period. Altogether he drafted 48 constellations. Some were named after mythological gods and heroes like Orion and Perseus, while others were supposed to represent everyday creatures and inanimate objects: the swan, the fishes, the cup. All Ptolemy's groups are still accepted, though their boundaries have been modified. Of course the sky was not completely covered, since the far southern stars were never visible from the Mediterranean area, so that some of the groups near the South Celestial Pole have strangely modern names, the microscope and the octant, for example. Astronomers of the 17th and 18th centuries were not slow to form new constellations, often by stealing areas from the other groups. Some of these have been accepted, and the total number of constellations is now 88, but others were tactically rejected. Perhaps this is just as well, since the names were cumbersome and the proposed groups totally unworthy of separate recognition. Typical examples are Sceptrum Brandenburgium, the Sceptre of Brandenburg, Officiana Typographica, the printing press. All of which, together with others, are to be found on the star maps drawn up by German astronomer John Elliott Bode about 1780. In 1922, a commission of the International Astronomical Union took the whole matter in hand and fixed the boundaries of the various constellations with great precision. Even so, it cannot be said that the system is logical, neither do the constellations in general have outlines which correspond even remotely with the objects after which we are named. It takes a highly fertile imagination to make a hunter out of Orion, a bear out of a great bear, or a ship out of Argo Navis. Only in a few minor cases, such as the Triangulum and Northern Crown, are the names reasonably appropriate. Another point of importance is that there is no such thing as a constellation in the real sense of the word. In most cases, the various stars in any particular group are not associated with each other and simply happen to lie in more or less the same direction as seen from Earth. To show what it meant, it would be best to consider Orion the Hunter, which is among the most spectacular of the constellations and which dominates the evening sky during winter and early spring. Orion is so distinctive that it can hardly be overlooked. It has 7 bright stars, of which 2, Betelgeuse and Rigel, are particularly prominent. The most casual glance shows that Betelgeuse and Rigel are entirely different. Rigel is almost pure white and is exceptionally luminous. A recent estimate makes it about 50,000 times as powerful as the Sun, and its distance from us is in the region of 900 light years. Betelgeuse has a strongly orange-red hue and is not so luminous, but to compensate for this it is of immense size. Its diameter is thought to be 250 million miles, 15 times more massive than the Sun, so that it is large enough to contain the entire orbit of the Earth. It is 520 light years away, so that the real distance between Betelgeuse and Rigel is comparable to the distance between Betelgeuse and us. On the other hand, Kappa Orionis, or Syath, the star in the lower left-hand corner of the Orion figure, has a distance of more than 2,100 light-years and is not truly associated in any way with either Betelgeuse or Rigel. Orion, then, is our first port of call, where the most famous feature is Messier 42, the Great Nebula, a misty patch just below the Hunter's Belt. Nicolas Claude de Présac, who was born on December 1st, 1580, in France, was the first person to discover the Orion Nebula in 1610, soon after the invention of the telescope. Messier 42 is of a type known as an emission nebula and is of magnitude +4. It lies at a distance of around 1,300 light-years and has a radius of 12 light-years. The Orion Nebula can easily be seen in binoculars or small telescopes, while its splendour can best be appreciated by positioning it just outside the field of view of a low-power eyepiece and allowing the nebula to drift across the field. An emission nebula is a cloud of ionised gas emitting lights of various colours. The most common source of ionisation is high-energy photons emitted from a nearby hot star or stars. Among the several different types of emission nebula are H2 regions, in which star formation is taking place, and young massive stars are the source of ionising photons. M42 is dominated by the trapezium, also known as C2 Orionis, which is a cluster of 5 bright stars formed out of the parent nebula. These 5 stars are in the order of 15 to 30 solar masses in size. They are within a diameter of 1.5 light-years of each other and are responsible for much of the illumination of the surrounding nebula. Nearby is the gaseous nebula Messier 78, which has an apparent magnitude of +8.3. On the clearest nights, it can be glimpsed with 10 by 50 binoculars, while the images appear to show the depiction of a running man in the dark dust cloud fronting the nebula. The long-period variable star U Orionis is orange-red in colour. It varies from +4.8 to 13 in a period of 368 days. At maximum brightness, which is expected at the end of March 2014, it is well within naked eye visibility, so now is the best time to observe it. The star lies to the upper right of Orion's belt. Returning to the line of sight effect of the stars, an even more graphic case is provided by Aldebaran in Taurus, the eye of the bull. A brilliant orange-red star almost in line with Orion's belt to the upper right, extending from it may be seen a pattern of several much fainter stars, making a rough V, are comprising the Hyades cluster. Aldebaran is an orange giant star located about 65 light-years distant. It is the brightest star in the constellation and is the 13th brightest star in the night sky. At first sight, it looks as though Aldebaran is situated in the Hyades, but this is not so. Aldebaran lies about halfway between the cluster and the Sun and has a different motion through space. The same principle may be applied to the planets, which are relatively very close. When we say that a planet is in a particular constellation, such as Capricorn or Aquarius, what we really mean is that the planet is seen against the background of totally unrelated stars, making up a chance pattern which has been given an arbitrary name. The centre of the Hyades lies at a distance of 130 light-years and is about 8 light-years in diameter, and the stars are believed to be 400 million years old. The Hyades are only a small part of the Taurus moving cluster, a loose aggregation containing many fainter members. The entire group is drifting slowly through space towards a point a few degrees east of Betelgeuse in Orion. Above and to the right of the Hyades is Messier 45, the Pleiades, also known as the Seven Sisters, which is the most famous open cluster in the night sky. The cluster is easily visible to the naked eye. You should be able to see several of the stars, while binoculars show the Pleiades beautifully. The cluster is dominated by hot blue and extremely luminous stars that have formed within the last 100 million years. The cluster is associated with dust that forms a faint reflection nebula around the brightest stars. The Crab Nebula, Messier 1, is located 1 degree northwest of Zeta Tauri, the star that marks the lower southern tip of the Bull's Horn. The nebula is at magnitude +8.4, so that the Crab Nebula is a fairly easy object in a 3-inch telescope. It appears oval like a tiny hazy globule. The Crab Nebula was formed as a result of a supernova explosion in the year 1054. The Crab Nebula is what astronomers term a planetary nebula, which is misleading since they have nothing to do with planets. The name comes from the round planetary appearance of their luminous shell of dust and gas. Other examples include Messier 27, the Dumbbell Nebula in Vulpecula, the Fox. Here is a splendid photo of M27 taken by Kevin Reid of West Yorkshire Astronomical Society. Although the constellations are mere line-of-sight effects, and few of them bear any resemblance to their chosen names, the old myths and legends are fascinating. Orion, for instance, was said to be the son of Neptune and Ural, and boasted that he could conquer any creature which Earth could produce, whereupon Juno, who was jealous of him, caused a giant scorpion to appear out of the ground and bite Orion in the foot, killing him. Some say the pleadings of Diana, goddess of hunting, led to his being placed in the heavens directly opposite the scorpion, Scorpio, so that he should suffer no further harm from it. Orion and Scorpio may never be seen together. When one is above the horizon, the other is below. Another legend relates how Diana fell in love with Orion and thus angered Apollo, who persuaded her to try her skill at archery by shooting at a certain object in the sea. She aimed and hit the mark, which proved to be Orion's head, who had been waiting in the waters. Diana's arrow having killed him, the goddess placed him among the stars. Orion, as befits a mighty hunter, has his retinue around him. In particular, there are two dogs, Canis Major and Canis Minor. The first contains Sirius, the brightest star in the entire sky. In point of fact, it is much less luminous than a giant such as Rigel, and is a mere 26 times as brilliant as the Sun, but it is also one of the nearest stellar neighbours and lies at a distance of 8.5 light-years. There are various other moderately bright stars in the group, but the outline of the dog is not well marked. About 4 degrees south of Sirius is a bright open cluster Messier 41, which is easily visible in binoculars. The cluster lies at a distance of 2,300 light-years and contains about 25 bright stars and many fainter members scattered over an area about the size of the full moon. There is an orange-red star near the centre that can be picked out with binoculars. VY Canis Majoris is one of the largest stars yet discovered. This red hypergiant sits 3,500 light-years away in the constellation of Canis Major. Its estimated radius is 1,420 times that of the Sun, and due to its extreme luminosity, it is viewable in binoculars. The star's magnitude varies from plus 6.5 to 9.6, half a million times brighter than our Sun. Some scientists say that VY Canis Majoris would extend past Saturn's orbit were it placed in our solar system. Having lost approximately half of its mass, VY Canis Majoris is an old star expected to have a mere 1 million years left of its lifespan before it erupts into a powerful supernova. Due to the star's size, temperature and energy, scientists have used VY-CMA to study supergranules, enormous cells of gas that are formed inside the star, rise to the surface, and are ejected out into space to cool into molecules. VY Canis Majoris is surrounded by an extensive nebula that shows condensations that are believed to be stars. The nebula has been extensively studied with the aid of the Hubble Space Telescope, which reveals a complex structure with filaments and arcs caused by past eruptions. These stellar events have been noted in other massive stars, such as Betelgeuse. Canis Minor has one bright star, Procyon. The rather barren area between the dogs is filled by Monoceros, the unicorn, which has nothing to do with Orion and was added to the sky by Hevelius in 1690. Also in the winter sky, another small constellation, Lepus the Hare, is one of Ptolemy's original 48, presumably because the legends tell us that Orion was particularly fond of hunting hares. Lepus is found, aptly enough, below the hunter's feet. Not far from Orion lies the constellation of Gemini, the twins. The twins themselves, Castor and Pollux, are represented by two bright stars and usually close together in the sky, but once more there is no real connection, since Castor is a full 10 light-years farther away from us. The two may be found by using an extended line from Rigel through Betelgeuse as a pointer, while the rest of Gemini is made up of several lines of stars extending roughly from Castor and Pollux in the general direction of Betelgeuse. Gemini is easy to locate at the moment because it is dominated by the brilliant planet Jupiter, which lies in the middle of a constellation. The bright open cluster Messier 35 lies a little above and to the right of the star Eta Gemini, Propus. It is visible to the unaided eye in the ideal dark sky conditions, while binoculars will show the cluster really well. Messier 35 covers an area the size of the full moon, and with small telescopes the region represents a glorious field, with stars ranging from magnitude +9 to 16. Jason's ship the Argo is also to be found in the sky, but unfortunately it lies so far south that little of it rises in Britain. Its leading star, Canopus, is the brightest star in the heavens apart from Sirius, but it can never be seen in our latitudes and only just rises above the horizon in Ptolemy's hometown of Alexandria. Argos is so huge that it has been convenient to divide it into several parts, of which the most important are Carina the keel, Mila the sails, and Puppis the poop. Another of Ptolemy's original groups is Auriga the charioteer, or wagoner. It is marked by one particularly bright star, the yellow Capella, which is almost overhead in Britain during winter evenings, so occupying the zenith position taken during the summer evenings by the equally bright bluish Vega. Close to Capella are three fainter stars arranged in a triangle, known collectively as the Hasdi or Kids. Upsilon Auriga, at the apex of the triangle, is an exceptionally interesting object which has puzzled astronomers for many years. New observations from NASA's Spitzer Space Telescope, in combination with archive ultraviolet, visible and other infrared data, point to one of two competing theories and a likely solution to the age-old puzzle. One theory is that the bright star is a massive supergiant, periodically eclipsed by two tight-knit stars inside a swirling, dusty disk. The second theory holds that the bright star is in fact a dying star with a lot of less mass, periodically eclipsed by just a single star inside a disk. The Spitzer data strongly support the latter theory. Upsilon Auriga is more than 2,000 light-years distant, whereas Capella, at only 45 light-years, is relatively close to us. The area of sky enclosed by the polygon of stars, which forms the main part of the constellation, is rich in star fields that are visible in binoculars. There are two relatively bright open clusters to be found here, Messier 36 and Messier 38, with Messier 37 just outside. Messier 36 is a young open cluster with approximately 60 stars, most of which are relatively bright. However, only about 40 stars are visible in most amateur instruments. Messier 37 is an open cluster larger than M36, and at a distance of 4,200 light-years, it has 150 stars, making it the richest cluster in Auriga. The most prominent member is an orange star that appears at the centre. An M38 is a diffuse open cluster at a distance of 3,900 light-years, the least concentrated of the three open clusters in Auriga. The mythological Auriga was Eratosthenes, son of Vulcan, the Olympian blacksmith. Eratosthenes was born deformed and was reared by Minerva without the knowledge of the other gods. When he reached manhood, he became king of Athens and invented the four-horse chariot, for which Jupiter rewarded him by placing him in the sky. Turning now to the northern groups, we must say something about the two bears, Ursa Major and Ursa Minor. The famous pattern of 7 stars making up the plough is only part of Ursa Major, though the rest of the constellation is inconspicuous. Ursa Minor contains a pole star, Polaris, which is highly luminous and which lies at a distance of nearly 700 light-years. Ursa Major was originally Callisto, attendant to the goddess Juno, and daughter of King Lyson of Arcadia. Her beauty surpassed Juno's own, and the jealous goddess was enraged as a result. To protect Callisto, Jupiter changed her into a bear. Unfortunately, Callisto's son Arcas saw the bear while he was out hunting and was about to kill it with his spear when Jupiter intervened, turning Arcos into a bear also and placing both animals among the stars. During winter evenings, the plough asterism, which is made up of 7 bright stars, can be seen standing on its tail in the north-eastern sky. The top 2 stars, American Dubhe, are known as the pointers because they lead the way across the sky to the pole star. When we come to the Fad, followed by the 4 stars of the handle, Megrez, Eliaf, Alcor and Elkad. Alcor and Mars are also known as the Horse and Rider. It is an easy double star visible in binoculars and is known to be a test for keen eyesight. In the field is another faint star known by the odd name of Sidious Ludwiganium. This is named by an eccentric German amateur astronomer, John George Leibniz, in 1722, who thought he had discovered a new planet and named it after a contemporary German prince, Ludwig Ludwig Hass of Darmstadt. However, the star Merak, one of the pointers, is of importance at this time of year. A little below Betelgeuse Majoris can be found Messier 97, also called the Owl Nebula, which is a planetary nebula 1,630 light-years from the Earth. It has a magnitude of approximately +10. Close by is Messier 108, which is a faint galaxy with a magnitude of +10.7. They can both be seen with a moderate telescope of 6-inch aperture, and they make ideal candidates for photographers. In the aerial sky above Cassiopeia lies a constellation of Perseus, the hero, which contains a famous double cluster, which is the name for 2 bright open clusters, NGC 884 and NGC 869. They are 7,600 and 6,800 light-years distant, respectively, and relatively close to each other in space. Their ages are estimated at 3.2 and 5.6 million years, which means that they are relatively young. The double cluster has a combined magnitude of +4.3 and can be seen without binoculars, but observing its cluster individually requires a small telescope. Another bright open cluster is Messier 34, which lies midway between Beta Persei, Algol, and Gamma Andromeda, Almag. It has a visual magnitude of +5.5 and lies approximately 1,500 light-years distant. It is between 200 and 250 million years old and contains about 400 stars. For me, the most celebrated star in the sky is Beta Persei, Algol, which means the eye of the demon. It was the first eclipsing binary star ever discovered and one of the first variable stars to be found. On the evening of November the 12th, 1782, an 18-year-old boy named John Goodricke was busy observing the stars. He was a serious astronomer, but an unusual one. He was deaf and dumb and had been so from birth. Fortunately, there was nothing the matter with either his eyesight or his intellect. Goodricke was particularly interested in Algol or Beta Persei. In the ordinary way, Algol is about as brilliant as Mizar or Polaris, but on this particular occasion something was happening to it. It was fading, and continued to do so for several hours until it had dropped to magnitude +3.5, when it started to increase once more, returning slowly to its usual brightness. Goodricke was not the first to observe this curious behaviour in Algol, since Giuliano Montiori, an Italian professor of mathematics, had noticed it as long ago as 1669. Yet nobody had explained it satisfactorily, and Algol was clearly quite different in type from the other known variable star, Mira, in the constellation of Cetus. Goodricke believed that he had the answer, and in the following year he wrote a paper in which he suggested that the changes in brightness shown by Algol were due to the periodic eclipse of a bright star by a dimmer binary companion. We now know that Goodricke was right, and it was a tragedy that this gifted deaf mute should have died soon afterwards, at the age of 21. Had he lived, he would have done much for astronomical science. Algol is easy to find. The best pointer to the constellation Perseus is Cassiopeia. An imaginary line from the 2 other stars in the view leads us to Merfact or Alpha Persei of the 2nd magnitude, and Algol is not far off. We can also use the stars of Cassiopeia to estimate the change in brightness of Algol. At maximum, Algol is slightly brighter than any of the stars in the W, while at minimum it is approximately equal to Epsilon Cassiopeia, the fainter of the 5. Algol is at maximum for most of the time, 2 days 11 hours it shines steadily, but then fades down to its least brightness in a period of 5 hours. As a minimum, a further 5 hours is needed to regain normal brilliancy, and then nothing more happens for a further 2 days 11 hours. In fact, Algol seems to wink regularly. The best way to show the behaviour of Algol, or any other star which changes in brightness, is by means of a light curve, and which magnitude is plotted against time. It will be seen that Algol is not absolutely constant for the whole 2 days 11 hours of maximum, but to measure very small changes in brilliancy naturally needs sensitive instruments. Over the last decade, astronomers have been discovering a great many extrasolar planets using the transit method, in which they carefully measure the brightness of the parent star as the planet transits across its disk. It's nice to think that John Goodrick worked out this principle 230 years ago. There is a rather interesting point about the name Algol, which is Arabic and means the head of the ghoul. A ghoul being a female demon with an unprepossessing appearance and even more unprepossessing habits. In classical legend, the star is equally sinister since it marks the severed head of the Gorgon, still carried by Perseus in the journey across the sky. This has led to the suggestion that the ancients knew all about Algol's curious behaviour, and it has been maintained that the star itself was regarded as thoroughly evil. Modern scholars disagree, and it is not now believed that the variability was known in ancient times, but it is certainly appropriate that Medusa's head should be marked by a winking star. Constellations added since the days of Ptolemy have no legends attached to them, such as the Lizard, Lacerta, the Little Lion, Leon Minor, and even the famous Southern Cross. However, other modern groups, such as Phoenix the Phoenix, retain mythological associations. Though astronomy has long since become an exact science, it still retains its aura of mystery, and the old legends are too fascinating to be forgotten. There are a lot of sights on view in the wintry night sky at the moment, many of which are visible in a pair of 10 by 50 binoculars. I anticipate that you are now inspired enough to go out into the garden and use binoculars to view some of the deep sky objects now on view. Please let me know how you get on. That's all we have time for this month. Thank you for watching. The next programme will be available from March the 1st, so please make a note in your diary. Until then, goodbye for now.